In this video, we are going to learn how to create a frequency distribution from raw data and also how to create a relative frequency distribution from raw data. So let's begin. A concerned mother thinks too many cars are speeding down the road where her children play. In an effort to increase awareness, she records the speeds of 20 cars traveling down her road. And here are those 20 speeds in miles per hour that she recorded. And we are going to make a frequency distribution from this raw data. So we are making this frequency distribution from scratch. So we're going to follow the part 1 steps on how to create a frequency distribution, and we have here in parentheses that we are going to do that with 5 classes. There will be times when I tell you how many classes to use, and there will be times when you yourself can decide how many classes you want to use for your frequency distribution. So step 1 is to determine the number of classes. In this example that was already given to us, we have 5 classes. Step 2 is to find the class width, and here we see highlighted in yellow that there is a formula for the class width, and it is equal to the maximum data value minus the minimum data value, all divided by the number of classes. And we will always round up to the nearest whole number. So from our data, our maximum data value, the highest miles per hour in this list is 51. So our maximum data value is 51. Our minimum data value, the smallest miles per hour in this list, is 25. So our minimum data value is 25. So now we have what we need in order to compute our class width. We will take the maximum data value of 51 and subtract the minimum data value of 25, and then divide that by the number of classes, which is 5 that was given to us in the problem. When we do 51 minus 25 and then divide that all by 5, we get 5.2, and we are going to round this up so that the class width is equal to 6. That is our class width. For step 3, we are going to find the lower class limits. And down here it says that the first lower class limit is equal to the minimum data value. Remember, our smallest data value was 25, so that will be our first class lower limit. The rest of step 3 reads, use the class width to find the rest of the lower class limits. So we are going to be adding the class width of 6 to 25 to give us the lower class limit of the second class. 25 plus 6 is equal to 31. We will add 6 again to find the lower class limit of the third class. 31 plus 6 is 37. We will add 6 again. That gives us 43. And finally, for the lower class limit of the last class, 43 plus 6 is equal to 49. So now we're ready to move on to step 4, which is to find the upper class limits. Step 4 tells us that the first upper class limit is 1 less than the second lower class limit. So the first upper class limit, whatever number goes here, is 1 less than 31, because that is the lower class limit of the second class. So our first upper class limit is 30. The second upper class limit is 1 less than the third lower class limit. So to find the upper class limit for the second class, I will subtract 1 from the third lower class limit to get 36, and we will continue in the same manner. If this starts at 43, then the third class must have ended at 42. If the fifth class starts at 49, then the fourth class must have ended at 48. And then to find the upper class limit of the last class, we will use the class width. Again, notice from 30 to 36, we added 6. That's the class width. From 36 to 42, we added 6. 42 to 48, we added 6. And finally, we will add 6 to 48 to find our last upper class limit of 54. We are now ready to move on to step 5, which is to count the frequencies. And that is why I have this last column of scratch work in this table. We will use the scratch work section to keep track of how many speeds fall into these different classes. So starting with the first class, we are going to go through the list and grab all of the speeds that are between 25 and 30 miles per hour, including 25 and including 30. Those two numbers are included in this class. So the first number we see, 25, that falls into this category. So I'll put a tick mark there for 25. 27 also falls into this category. Moving down the list, we have 28 that would also fall in here. We have another 27 that lands in that category. Continuing down the list, we have 29 that is in that category, and the remaining numbers are larger than 30, so they will not be in the first class. So the frequency for the first class is 5. Moving on to the second class, we need all the numbers between 31 and 36, including 31 and including 36. So the first one we have is 35. We have 33, gives us our second one. 31 also falls into that category. 34 would also be in this class. 32 would also be in this class. And the last one we would have would be 36. So the frequency of the second class is 6. Moving on to the third class, we need all the numbers between 37 and 42. So the first one we'll grab is 42. Continuing down the list, we have 40. So I'll grab 40. I skipped over 39 here. 39 is also going to be in this list, so I'll add a tick mark for that. And 42 would also fall into that category. So the frequency for the third class is 4. The fourth class, we need the numbers between 43 and 48. 46 falls into that category. So does 47. 44 would also be in that category. And we have another 44 that we'll grab. And that is it for the fourth class. So its frequency is 4. And then finally for the last class, numbers between 49 and 54, we only have one speed in that category. That's 51. And so the frequency for the final class is 1. Remember, a way to check over your work is to add up all of your frequencies. If I were to do 5 plus 6 plus 4 plus 4 plus 1, that adds up to 20, which is good because we know that she recorded the speeds of 20 cars traveling down this road. So the sum of all the frequencies should be 20. In part 2 of this video, we will be making a relative frequency distribution. So to start this table off, our first column will be exactly the same as the classes from our frequency distribution table. We're still using the same classes, so I'm going to go ahead and copy over these speeds. For the first class, we have 25 to 30. Second class is 31 to 36. Next is 37 to 42. Then 43 to 48. And finally 49 to 54. And to construct this relative frequency distribution, we are going to compute the relative frequencies for each one of these classes. So we have the relative frequency formula over here to the right that tells us that the relative frequency is equal to the frequency divided by the sample size. Remember, in this example, our n is equal to 20. That's how many cars she recorded the speeds of. So let's start computing our relative frequencies. For the first class, the frequency of the first class is 5. So that fraction is going to be 5 divided by 20. That is the frequency divided by the sample size. 5 divided by 20 reduces to 1 over 4. which as a decimal is 0.25, and as a percentage is 25%. For the second class, its frequency was 6. So we have 6 divided by 20 when we compute its relative frequency. That simplifies to the fraction 3/10, which is equal to the decimal 0.3, which is 30%. We get from the decimal to the percentage by moving the decimal place 2 places to the right and adding the percent symbol on the end. For the third class, it had a frequency of 4. So we have 4 divided by 20, which simplifies to 1/5, which is the decimal 0.20, which is 20%. For the fourth class, its frequency was also 4. So that's going to be exactly the same as the third class. We have 4/20, which is 1/5, which is 0.20, which is 20%. And then finally, for the fifth class, it had a frequency of 1. So its relative frequency is 1/20, which is already a simplified fraction. As a decimal, that would be 0.05, which is 5%. And this is our relative frequency distribution. Notice that if we add up all of these percentages, we do get 100%. 25 plus 30 plus 20 plus 20 plus 5 gives us 100%. So now let's look at part 3, where we try to make an inference based off of this data. Part 3 reads, the speed limit on this road is 35 miles per hour. Based off of the mother's data, what could be said? So let's try to say something about what percentage of people are speeding on this road. So if we want to make a conclusion about speeding, the speed limit is 35 miles per hour. So definitely everyone who falls into these last 3 classes that start at 37 and then end at 54, all of those drivers are speeding. So we have from the third class between 37 and 42, 20% of those drivers. Between 43 and 48, we have another 20%. And then finally, between 49 and 54, we have 5%. So if we add up all of these percentages, we can say that about 20 plus 20 plus 5 gives us 45%. About 45% of the drivers are speeding. And that is the end of our video on frequency distributions and relative frequency distributions from raw data.